Hello all, welcome back to my YouTube channel all about VLSI. In our previous sessions, we have discussed about functional coverage and we have also seen what are the bins and we have seen one example of how we are going to perform coverage. And also we have started with the verification of our project decoder-based RAM in which we have discussed about all the particular type of test cases which we were having. And also we were discussing about the type of test cases which we have and what verification engineers do and what are the different test cases which we can have, and also we have discussed about interface file, generator, transaction, and write driver and read driver files we have discussed in our previous sessions. Now it's time to develop the another file in our particular project, which is nothing but now let us try to develop a write monitor file. So this particular write monitor file is going to have the particular contents. Let's first of all understand how the architecture is going to look like. So this is my design DUT. To this particular design, we were developing multiple test cases, and from this multiple test cases, we were giving it to our environment, and from the environment, the stimulus was given to our generator. The test cases were given to our generator, and generator is basically randomizing my transaction file, and this transaction file is being randomized and it is being sent to my write driver. So this particular generator is driving the transactions to my write driver, and via the mailbox it is basically driving the transactions via the mailbox, and also the read driver is also driving the read related transactions to our design. So that was a job of our read driver and write driver. Via the mailbox, the generator was giving those particular transactions to my write driver and read driver, and write driver is further driving it to my design, and read driver also driving the read related signals to my design via the interface. Now, we will develop one more component over here in this particular session, which is nothing but my write monitor. Now, what is this write monitor going to do is whatever the write driver was driving, those particular signals we will try to sample it. Okay, so whatever the write related signals which my write driver was driving, we will try to collect it from the interface to this write monitor. So this is what we are going to do, and over here the duty of this write monitor is to monitor whatever the write driver is driving. That is the duty of this write monitor, and why it is being monitored, that we will discuss later. Okay, so our duty is to develop a monitor, and what we are going to do with that particular things we will discuss. Okay, so write monitor is monitoring the transactions which our driver was driving, and after sampling them from the interface, write monitor is going to give those particular transactions to one more component which is known as scoreboard, and another component which is known as reference model. So after sampling the transactions from my write driver via the interface, it is going to give those particular transactions to scoreboard and reference model via the mailbox. So it is going to give those particular transactions to this components via the mailbox, and it is going to collect those transactions from the interface via the write driver. And after collecting the transactions from the interface, the monitor is going to store them internally in a transaction object. It is going to have its own transaction object created, and in that particular transaction object, write monitor is going to store them, and this particular transaction object is sent to scoreboard and reference model via the mailbox. This we are going to have it, and what is scoreboard and what is reference model we are going to discuss later, but this is what we are going to implement. Okay, now let's open the playground. So in the EDA playground we were doing interface and read clocking block, and we were having modpots and everything in the interface and transaction, and also the generator file we were having. And next we have developed the write driver file, and we have also developed the read driver file. And yeah, up to here we have done, and let's start the development of write monitor. So let me declare write underscore monitor, and over here this write underscore monitor we have declared. And since we need to collect the fields, since we need to collect the data from the interface, we need to have the interface handle declared inside my class. So I'm going to declare the virtual interface handle over here. The interface handle is ram underscore if I'm not wrong, let me check. Yeah, ram underscore if is my interface handle name, and followed by dot write underscore monitor is my clocking block name, and VIF is my interface handle name. Now let me declare two mailbox handles over here. Mailbox RAM underscore transaction. Let me check the transaction class name over here. It is just transaction. So let me declare it over here. Mailbox transaction. And the mailbox name is scoreboard underscore write underscore mailbox. So I've shown you right over here from the right monitor, we need to give the data to the scoreboard via the mailbox. So that's the reason I'm declaring over here. And mailbox transaction, it can only send the transaction data. And scoreboard underscore, I need to send it to the reference model via the mailbox, right underscore mailbox. So these are the two mailbox handles I've declared. And let me declare one internal variable unsigned observed underscore count, just for observing the number of transactions we are going to send. And I'm going to have a new function over here because this particular new function in my right monitor will help us to get the interface handle which has been declared inside my in my top, the interface instance which we have created in the top. That interface instance can be passed from my test to environment to the generator to the right monitor via the new method. And also the mailbox instances which we were created in the environment, which we are going to create it in the environment, that instances can also be passed from the environment to the generator to the right monitor. So how I'm passing and why I'm passing and why I'm not creating the instances in my right monitor. If you want to learn about that, you can refer to the mailbox session which we have discussed earlier in the playlist. You can refer that. It will give you a clarity of why we are doing such. Okay. And here let me declare the new function. And over here, I'm going to declare virtual RAM underscore interface dot write underscore monitor VAF. This instance will be given by our environment, and mailbox hash transaction, and the mailbox name is scoreboard underscore write underscore mailbox, and mailbox hash transaction reference model underscore write underscore mailbox. So these are the two handles which I have declared, and this will be passed from my environment, and here it is come up. Okay. And that's it. This is my new function which I'm going to have, and I'm going to copy it to the local handles. This dot VAF is equal to VAF, and this dot scoreboard underscore write underscore mailbox is equal to scoreboard underscore write underscore mailbox, and this dot reference model underscore write underscore mailbox is equal to reference model underscore write underscore mailbox, and followed by end function. So this is what I have done over here. And let me declare a task which is known as run task. Over here, let us declare a task which is known as run task. And this task, we are going to create the transaction instance TXN, and the transaction class name is just a simple transaction. And let us display something like process started $display right monitor started. So I'm going to display. And next, within a forever begin block, I'm going to wait for my VF dot clocking block. So at this particular instance of clocking block, I'm going to basically I'm going to check for my write enable signal. If VIF dot monitor underscore CB, that is clocking block dot write enable, if it is equal to 1, if write enable if it is equal to 1, using the clocking block instance I'm checking it, then I'm going to create my transaction class instance, and also I'm going to make my txn.op is equal to right. What is this txn.op is equal to right? You need to verify the previous lectures. We have discussed what is a field op which has been declared inside my transaction class, and txn.address which is equal to interface dot monitor clocking block dot address, and txn dot w data which is equal to vaf dot monitor underscore cb dot w data. Okay. And txn dot valid, we are going to make it as 0 over here, and we are going to increment observed underscore count plus plus. Okay. And I'm going to print the transaction, whatever the data fields which I'm going to have read, that I'm going to print it, the values I'm going to print. That's it. And followed by after getting them. So what I've done now, I'm basically trying to extract the information which is present inside my interface to the right monitor transaction object. So whatever the object which I've created in my right monitor, to into that I'm trying to copy the interface instances. That's it. Or the transaction data items which are present inside my interface, which was driven by my write driver. That I'm basically copying it to my write monitor transaction object. After that, I need to send this particular transaction object to my scoreboard and reference model via the mailbox. So how I'm going to send it? Simple. Scoreboard underscore sb underscore write underscore mbx dot put of txn, and I can call the copy method which is present inside my transaction object. And reference, let me see whether I have declared the copy method or not in my transaction class. In my transaction, where is my transaction generator? Transaction. Okay, I haven't declared any copy method. Okay, not an issue. Just we are going to send the transaction. And reference model underscore write underscore mbx dot put of tx. That's it. Okay, and followed by end and end task and end class. So just write monitor is monitoring whatever the transactions which was driven by your write driver, and it is copying from that interface, and it is basically copying into the transaction, and after that it is sending that particular transaction objects to my scoreboard and reference model. And in our next session we will try to include the functional coverage things inside my write monitor, but later on. First, let us try to implement the read monitor and scoreboard and reference model, and let us check whether it is working or not. And later, while writing the test cases, let us include the functional coverage. Okay. Yes. So that's about this particular session. Thank you.